Okay guys, right here we have a video on reviewing the different factoring methods that we should already know, okay? Before we even begin with the different factoring methods, let's talk about why we want to factor and what factoring is. Factoring is really a reverse distributive property. So for example, if I had 3 times x plus 2, we already know that if we distribute, we will get 3 times x, which is 3x, and 3 times 2, which is 6. So factoring is a reverse distributive property method. It's doing this backwards. It's like if I asked you factor this, and the answer, let's pretend that you don't see this right here. Okay, so factoring this would ask you to give me the answer, which would be this up here. It's like doing it backwards, okay? And the way to do that in this case would be to factor out the GCF. What is in common here and here, right? Well, there's a multiple of 3, a multiple of 3, so you could pull out the multiple of 3. And if you do pull out that multiple of 3, you're going to have the 3 on the outside, and you'll have an x plus 2 left over on the inside. Okay, once again, that's a factoring method, but we said that we wanted to explain why we want to factor. Again, factoring is a reverse distributive property. And if we understand right here, it says something plus something, and when it's factored, you end up with something times something. That's very important to understand why we factor. Check this out. We have 3 different fractions here. This one says 3 times 2 divided by 3, because a fraction is really a division problem. This says 3 plus 2 divided by 3, and 3 minus 2 divided by 3. Now, what is 3 times 2? That is 6. So imagine this. It really says 6 divided by 3. And what's 6 divided by 3? The answer is 2, right? Now, when there is multiplication, you are able to just cancel out what's on top and bottom. So that's why 3 over 3 is really 1. It cancels out, and your answer is 2. You see the same answer is there. You cannot cancel the 3 over 3 here, because this is really a 5 divided by 3, okay? 5 divided by 3, and 5 divided by 3 does not equal 2, right? We know that 6 divided by 3 equals 2, not 5 divided by 3 equals 2. So you cannot cancel out here. They would be incorrect to cancel these 3's out. So the first basic thing that you need to understand is that you could cancel when there's multiplication. You cannot cancel when there's addition or subtraction. You cannot cancel the 3's here either. So like if I had 2 times 5 times 7 divided by 3 times 7 times 2. Okay, now I could actually multiply 2 times 5, 10, times 7 is 70, and 3 times 7 is 21, times 2 is 42, and then I could reduce that fraction to get the answer. But since there's pure multiplication everywhere, I could just cancel things out, like the 2's cancel out, the 7's cancel out. My answer will be 5 over 3. Ta-da! It's beautiful when we have multiplication, because we could cancel whatever you see up on top and on the bottom, whatever's alike on top and bottom. It's not so beautiful to see a plus sign, because you can't cancel, right? If it's a 2 plus 5 plus 7 and 3 plus 7 plus 2, I mean, you can't really cancel out anything. You'd have to actually add them all up, and then see if you could reduce. So do we understand that we like having multiplication instead of addition? Why? Because we're able to cancel. And that's what factoring really is. It's where you have something like 2x minus 8, and you want to get multiplication. Now right here it's not multiplication, it's something take away something. But if you factored it, pulling out the GCF, you could have a 2 out here, and then you'd have an x left over in here and a minus 4. Now it really does say 2 times something. And that's why we're able to cancel if you had it as a fraction. Okay, so we want multiplication. We don't want addition or subtraction, because you're not able to cancel with addition or subtraction. And this is why we factor, to get that multiplication. So we've been talking about factoring out a GCF. It's just whatever is in common, all right? So let's say I had 4x squared minus 8x. Well, what's in common in both terms? What do I have here? I have a multiple of 4. There's also a multiple of 4 in here. And there's also actually 2 x's here, x times x right here. And there's 1 x right here. So what is the greatest common factor that I could pull out of both terms at the same time? We put parentheses here. We could definitely pull out the multiple of 4, and we could pull out a single x. This is factoring. It's a reverse distributive property. If it were distributive property, you'd go 4x times what would get you that 4x squared. So 4x times what would get you that 4x squared? That would be a single x. And then 4x times what would get you a minus 8x. Well, to change the 4 to an 8, you're going to have to multiply by 2. And to get that minus 8, you have to put a minus 2 right there. So let's all put a minus 2 right there. And this is factoring out of GCF. Pretty easy, right? You just look at all your terms and pull out what's in common. Let's try one with 3 terms instead of 2. So right here we have 4x to the 5th minus 8x to the 3rd plus 18x squared. Is there a 4 in common, the multiple of 4? There's a 4 here. There's 4 times 2 is 8. 4 times, nope, it doesn't work. So 4 didn't work. Let's try something else. How about 2? Yeah, 2 times, they're all even numbers, so you could definitely pull out the multiple of 2. So let's put our parentheses here. I'm trying to pull out the GCF. By the way, this is the first factoring method we learned a long time ago. This is always the first factoring method you should attempt. Pull out what's in common. If there is nothing in common, then you try other things, other factoring methods. So let's pull out this 4. We're going to have actually a 2. Pull out a 2. And how many x's could we pull out at the same time from all 3 terms? Well, there's 5 x's here. There's 3 x's there. There's 2 x's there. We could pull out a maximum of x squared. 2x squared is the GCF. And then you think 2x squared times what will get you that 4x to the 5th? Well, 2x squared times 2x to the 3rd. Remember, when you're multiplying, you really add exponents. 2 plus 3 is 5. And then 2x squared times what will get us that negative 8x to the 3rd? Well, that'll be a negative 4 with a single x. And then 2x squared times what will get us a positive 18x squared? Well, that's just going to be a positive 9, no x's, right? Because x squared is already here. X squared times an invisible 1 will get you that x squared. This is factoring out of GCF. So like, let's say I had 4x to the 5th minus 8x to the 3rd plus 18x squared. Okay, it's totally separate, right? Let's say I had this above a 2x squared, and I asked you to simplify it. Okay, well, could you cancel out this 2 with this 4? No. Could you cancel out this x squared with that x squared? No. Why not? Because there's addition and subtraction. Again, you want pure multiplication, right? So you go through this and you factor whatever you can out of here, which would give you this, right, when you factor it. So you'd be able to rewrite this thing. You'd be able to rewrite it as 2x squared, parenthesis 2x to the 3rd minus 4x plus 9 over the 2x squared, right? So I just rewrote this to that by factoring out the GCF. And then I would be able to cancel the entire 2x squared with this entire 2x squared. Why? Because it's being multiplied right here. It says something times something. Because there's multiplication, you're able to cancel. Up here, you were not able to cancel because there was addition and subtraction. Now, you're probably thinking, well, there's addition and subtraction in here. Yeah, that's true. But what do we really have here? We have something multiplied by something else. A monomial multiplied by a trinomial. And you're canceling out this entire monomial with that entire monomial. So this guy cancels out with this guy. And there's your final answer, 2x to the 3rd minus 4x plus 9. Okay. Now, that's barely the first type of factoring method. Another factoring method would be factoring quadratic trinomials. What's a quadratic trinomial? Quadratic is power of 2, trinomial 3 terms. Where you have, there's a standard form quadratic trinomial. This is from semester 1. Ax squared plus bx plus c when a equals 1. That's why I put this in blue. Because this is really easy when the a value is 1. In other words, when there's no number in the front. So on the assignment I gave you this week, there are several of these quadratic trinomials where the a value is 1 within the problems. So if you look at number 17 right here, we have a quadratic trinomial. Let me do this. Let me get this out of the way and make a copy of this guy. And as you can see, just pretend the parentheses aren't there. I cut it from that homework. But as you can see, the a value here is 1, the b value is also positive 1, the c value is negative 20. So we have a quadratic trinomial, and we need to know how to factor this. Whenever you have a quadratic trinomial where your a value is 1, you should, most of the time, be able to rewrite it in this factored form with a single x right here and a single x right there. Now, why is this true? Because when you do distributive property, remember factoring is a reverse distributive property. If you were to do distributive property, you would begin with x times x, which would give you this x squared. So that's why we set it up like this, parenthesis, 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 xx, because this first term is x squared. If the a value were like 5, then we wouldn't be able to do this xx, because x times x is not 5x squared. So if you ever have a number right here, we have to use a different factoring method. So right now, we're factoring quadratic trinomials where the a value is 1, okay? So when the a value is 1, you could simply jump right into what times what is c that if you combine gives you b. This is it right here, guys. Again, what you're asking yourself is what times what is the c value, which happens to be negative 20, that if you combine gives you the b value, which happens to be positive 1. Now, if you struggle with this, if you're not that good with multiplication tables, get your calculator out, all right, and just make a list. How could you actually get negative 20? All right, well, to get negative 20, you can make a list. Negative 1 times 20, negative 2 times 10, negative 3 doesn't work, negative 4 times 5, and that's about it. Those are all the possible combos of getting two numbers multiplied together to give you negative 20, besides changing signs, all right? So when you take these numbers and combine them, 20 plus a negative 1, 20 take away 1, that's 19. This middle value is not 19. Again, you want what times what is this that if you combine gives you this. So when you combine these guys, it gives you 19. This is not 19, so this is not it. When you combine 10 and negative 2, that gives you 8. This middle value is not 8, so that's definitely not it either. The last one, 4 and negative 5. When you combine 4 and negative 5, it does give you a positive 1, and this b value is a positive 1, so this is the right pair of numbers, and you're going to take the negative 4 and the 5 and put them right here. Negative 4, positive 5. Negative 4, positive 5. And you're done. You factored it, okay? So we need to be able to factor quadratic trinomials when the a value is 1. It's the easiest thing to do. Just think what times what is the c value that if you combine together is the b value. So now that we know that, we should be able to do questions like 17, okay? Now, 17 is a really easy problem. Why? Because notice you already have this up here factored, so do not distribute. That'd be pointless. You already have something times something times something, and down here you have something times something. So what we're going to do is rewrite this guy. We're going to factor this guy, okay? After all, on these problems, you always have to try to factor first to get the multiplication, and then cancel things out once you already have the multiplication. So when we look at this inside quadratic trinomial, we already know that it could factor to x. What times what is negative 20, that if you add together is positive 1. It's going to be a positive 5 times a negative 4. So what we really have is on the bottom, we have a 6x times x plus 5 times x minus 4. So I already rewrote that bottom one. I'm just going to put a line through it because this is the same exact thing as this. Up on top, I have an x plus 2. Down here, I have no x plus 2's. Up here, I do have a binomial x minus 4. Down here, a binomial x minus 4. So I could cancel out that x minus 4. Like I said, I cannot cancel the x plus 2 with the x plus 5. Can't cancel this x with that x because there's a plus sign involved. When we look at this outside x squared, what does that really mean? That really means x times x. So we do have multiplication within this monomial right here. And down here, we also have a monomial 6 times x. So we do have multiplication in this monomial. So I could actually cancel out this x that's being multiplied with 6 and one of these x's that's being multiplied with another x, right? X times x. So we could also cancel out this single x with one of these x's, leaving you just one x up on top. So what's my final answer? My final answer is this single x times the x plus 2 over x plus 5. There's my answer. I cannot cancel the x with the x. Why not? Because there's addition involved. So that's about it. I mean, we could also state one extra thing, that x, or you could put but x cannot be negative 5. As a matter of fact, this book doesn't give this extra part of the answer, but it's a good thing to know, because anytime you have a fraction with a variable in the denominator, you want to avoid the x value that'll make the whole thing undefined. And we know that whenever we have a fraction, you do not want this whole thing to become 0. You don't want it to equal 0, because if it did equal 0, it would make the whole thing undefined, and that would mess it up. So whenever you have a fraction with a variable in the denominator, if you didn't have an x, then you don't have to do anything. But since we do have an x down here, x plus 5, what you could do is just say, I don't want that denominator x plus 5. I do not want it to be equal to 0. And then you just solve it. Minus 5, x, we do not want it to be negative 5. So that's how you get the extra part of your answer. Okay, like I said, this book on this section doesn't even give you this extra part of the answer. This is your answer right here. That's your answer right there. Whoops. Probably shouldn't have. There you go. That's your answer, but I want you to just throw in this extra part that x cannot be negative 5. So as you could see, guys, we're using factoring methods to be able to attain multiplication, to be able to cancel, because if you did have addition or subtraction, you cannot cancel. So there's here's another factoring, x squared minus 9. Now, this is technically, if you wanted to rewrite it as a quadratic trinomial, you could say that it's x squared plus there is no x minus 9. And then you could think, okay, what times what is negative 9 that if you combine together is 0? Well, that's easy. It's plus 3 minus 3. So I've just rewritten this guy to look like these two parentheses, x plus 3, x minus 3. Okay, and then you could cancel out the x plus 3 up here. You could cancel out with this x minus 3 up here. You could cancel out with that x minus 3 down there. And then you could continue, right? And this one right here is a difference of two squares, right? If you have a perfect square term with a minus in between, you could set up your factored form format and simply do the square root of the first one, which will be x. You could do the square root of the last one, which will be z, and you could repeat it, x, z. And since there is no middle term, we know it has to cancel out. So one has to be plus, one has to be minus. So I have factored this other one. And as you could see, we have an x plus 0 up here, x plus c down there, so we could cancel those guys out. And what's our final answer? What's left over? X plus 3 times x minus 2 over 4. X plus 3 times x minus 2 over 4. And we don't have to state anything extra because there's no variable in the denominator. This is your answer. You don't have to say, but x cannot be 5 or x cannot be 4. X could be anything because you'll never get 0 in the denominator. No matter what you plug in for x's, you'll never have this whole thing become undefined. So if I had an x down here, then I would say, okay, 4x cannot equal 0, and then I would solve, which means x could not equal 0. But there is no variable in the denominator, so you don't have to put any extra part on your answer. That's your answer right there. I hope this video helps. There are definitely more factoring methods, but for this homework, that's about all you need, right? Quadratic trinomial, right here. All you got to do is think what times what is negative 24, that if you combine together is 2. Do the same for the bottom. Cancel whatever you see alike on top and bottom.